Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC, which became effective in May-June 2018. As of January 2026, this syllabus has not been revised, but there are plans to change the structure of the exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to this CSEC level math exam is to split the exam into two parts. The current structure or format of the CSEC math examination, there is a paper 1 for 1 hour and 30 minutes, and it consists of 60 multiple choice items from all sections of the syllabus as outlined below, all sections. There is also a paper 2 for 2 hours 40 minutes, and this consists of 10 compulsory structure type questions from all sections of the syllabus. There will be no choice. All sections will be tested, as I said, with compulsory questions. And then there is a paper 031 if you are a student writing this exam through school. That is called school-based assessment. So your teacher will give you certain instructions and you will conduct an investigation, collect data, and then do certain statistical analyses on the data to draw some conclusions. That is, if you are a student in school. If you are not a student in school and you're writing this exam as a private candidate, then paper 3 will be 032, where you will be given data and asked to do certain statistical analysis on that data during this exam. As it relates to the profiles and the marks and so on, you have 3 profiles: knowledge, comprehension, and reasoning. And paper 1 has 18 items on knowledge, 24 items or 24 marks on comprehension, and 18 on reasoning, and so on, paper 2, paper 3. Eventually, your total marks is 200, and that will be expressed as a percentage to determine your final grade. Schedule of videos, sections 1, 2, and 3. All 51 of those videos have been published on YouTube in their entirety. Please make good use of them. Section 4, 5, 6, and 7. Some of these videos have been published on YouTube in their entirety, as seen here. The others, partially. We are now at section 8, geometry and trigonometry, and this is the 19th of 26 videos from this section. Of course, once section 8 is finished, we will still need to go on to section 9, and that schedule may have to be pushed back a little. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. Still on section 1, number theory and computation, because of its importance. As I said, I have divided that into 33 videos, and they are all available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. You need to know section 1 very well. If you plan to write this exam, you also need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Still on section 1 of this syllabus, some or most of these videos are even applicable in primary schools, where students can look at the videos before the class or after the class on that topic. Teachers can use it in the inverted classroom, and especially parents who may have forgotten this work and want to help their children. The parents and the child could look at the video together and then the parents could ask the child to go over back the work using the same examples in the video. So it will be of great help to parents, especially in primary school. And I'm talking about section 1. For example, if I expand that part of section 1, you will notice video 6 says add, subtract, multiply, and divide whole numbers. That is work normally done in grade 3 of primary school. And video 7 says add, subtract, multiply, and divide decimals. That's work done in grade 4. Video 8, add and subtract fractions, and video 9, multiply and divide fractions. So work done, these two, in grades 5 and 6 in primary school, and so on. You have order of operations, you have LCM and HCF, and conversion of fractions to decimals and percentages, and so on. Work that normally should be done in primary school. But remember, this is section 1 of the CSEC syllabus. If you are looking at this video, you are at this channel, ROEL922 on YouTube. If you rearrange it into playlists, you will notice a number of playlists, and the one we are interested in right now for section 1 is this one, section 1. As I said, most, if not all, of section 1 is work that should be done in primary school. Don't be misled by the title, CSEC Mathematics Section 1, Number Theory and Computation. It may look a bit difficult if you don't know what is in that section. Section 2, Consumer Arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, Measurement. Some of these have been published on YouTube in their entirety, as indicated here in yellow. The others are partially published on YouTube. Now, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, Statistics. Same principle. A number of these have been published on YouTube in their entirety, the others partially. And again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, Algebra, a section that most students have difficulty with. So 7 of these videos have been published on YouTube in their entirety, the others partially. Section 7, Relations, Functions, and Graphs. This is even a little more difficult than the last section, Algebra. So 9 of these videos have been published on YouTube in their entirety, the others partially. But even those that are published partially, they do deal to a certain extent with these objectives, with these specific objectives. Again, please see directions in the description below for full access to those videos that are only partially published on YouTube. Before we go on, recall I said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these that you see on the right here. From those, I would recommend these last 2 down here, as seen on the next slide, because they form a very good 2-volume set of math textbooks that is quite adequate for the current and future proposed changes in the structure of the CSEC math exam. This is a picture of Volume 1, Mathematics, a Complete Course with CXC Questions by Raymond Tulsi. And this is a picture of Volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available, free of cost, that deals with past CSEC math questions, specifically from paper 2. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like. This is the home page. You would have to register first and then, of course, sign in subsequently. Again, that is the URL. It will be in the description below, so you can easily click on it and be redirected to this math website. Just another reminder that this formula sheet is provided for CSEC math examination papers. It is included in a full copy of the syllabus. In case you don't have a full copy of the syllabus, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet. I am stating the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So section 8, geometry and trigonometry. We have completed this first page here, which is a print screen from this section of its objectives. Completed all of those. From the next page, objective 5, we have completed that. From the next page, objective 6, we have completed that. From the next page, we haven't finished with this page yet. We have finished 7, we have finished 8, we have finished 9, and we are now at objective 10, which is video 19 from this section. After that, we'll have to do objective 11, which is fairly easy. And then this is the final page with the remaining objectives from this section up to objective 17. So as I said, we have reached up to here, video 18. From those 5 have been published in their entirety on YouTube, the others partially. We are now here, video 19, which is objective 10. When I am finished with this, it will be published in its entirety. As it relates to the rest of these videos in this section, these 3 others will be published in their entirety and the other 4 partially. So from this section, a total of 9 videos out of 26 will be published in their entirety. And as I said, even those that are published partially, you can still learn something from them as they deal partially with the objective. For example, this one here, draw and measure angles and line segments accurately while it is only published partially. Some of the work is there in that partial video on YouTube. So as I said, we are here, video 19, and it says, describe a transformation given an object and its image. And we will be looking at these transformations here, which is translation. And by now, we have to use vector notation. We will also be looking at reflection, mirror line, which is the axis of symmetry. Rotation, we'll have to find the center of rotation, the angle of rotation, and the direction of rotation. Remember, you will be given the object and its image now. And finally, enlargement, the center of enlargement and the scale factor, K, under these conditions, where the absolute value is greater than 1 or somewhere between 0 and 1. This absolute value is called the modulus. So we shall now describe 12 transformations given the object and its image in each situation using the template shown below. Now remember, in the last objective, we were talking about orientation, similarity, and congruency. Now you will be given an object and its image, and you have to state the transformation. So this is a roadmap we shall follow. Geometric transformation. First of all, is the image congruent with the object? Or is it more than that? Is it similar? If it is similar, we can conclude enlargement. If it is congruent, then we have to make a choice among these three. If every point moved to corresponding points in the same direction, then we can certainly say that translation took place. Of course, besides that, we have to say in what direction. Remember, we are still dealing with congruency. Do we have lateral inversion? Left becomes right. If that is the case, we can most likely say it is reflection. There may be an exception to that. If we have a different orientation, still dealing with congruent shapes, then in that case, most likely it is rotation. So this is the roadmap we shall be following in this objective. So we begin with example 1. You have two shapes here. Consider the diagrams. Now, AB here is equal to A prime, B prime, AC down here is equal to A prime, C prime, and angle A, which is this one, is equal to angle A prime, which is this one. So really, that information is for you to determine, are these two shapes congruent? And yes, we have two sides of a triangle and the angle between being the same in both the object and the image. So they are congruent. So we have to describe the transformation of the object into the given image. So looking at this, you realize it's the same shape, the same orientation. So it's congruent and it's the same orientation. It's like you take this shape here and move it up across like that. So you can safely say it is translation, but you are not finished. You have to say what translation exactly is it. So let's consider a point here and its image over here. If you go across this way until you reach exactly under that C prime and you go up, how many places did you move this way? And the answer is 10. Remember, that's a positive 10. And up this way, it's 3. That's a positive 3. It's like you're dealing with the x-axis and the y-axis. So the translation under the column matrix is T, and you write it like this, 10, 3. We can stop there if this was given on a graph paper. But now let us say it is not given on a graph paper and you're told that the point A on the object, which is negative 7, 1, which is this, became under a transformation A prime 3, 4, which is this. It is a translation. What is the translation vector? So you're not given this diagram, but you are given that data, that information. So how do you go about doing that? So recall this. Any point on the image minus any point on the object is equal to the translation vector. So we will do that down here. The point we have on the image is 3, 4. Set that down there. The point we have on the object is negative 7, 1. We will subtract that. And if you subtract that, we will get the translation vector, which is 10, 3. 7 minus negative 7, which is 10. 4 minus 1 is 3. So you get 10, 3, which is that same 10, 3 we have down here. So we look at two ways of doing this. The easy graphical method and the little more difficult calculation method. That was example 1. Example 2. Consider the diagram below. Describe the transformation of the object into the image. Okay, this is diagram. By now you could just look at that and see that this one is larger than that one. So you can maybe comfortably say, I think we have enlargement. But let us make sure that these two triangles are similar. It says angle B is equal to angle B prime. So that angle is equal to this angle. Angle A is equal to A prime. So that angle is equal to this angle. And angle C is equal to C prime. that angle is equal to this angle. So yes, three angles, three corresponding angles being equal would make that similar triangles. This is the object, that is the image. So similar triangles and the same orientation. So we can safely say this is enlargement, but we are not finished. We still need to determine the center of enlargement and the scale factor, K. To do that, it's fairly simple. Draw pattern lines through corresponding points. So B prime to B and extend it. You do the same thing for C and C prime. You only need to do two of those, but I have done all three here. Pattern lines, 1, 2, that would suffice, but I have also done the third one. The point where they intersect is the center of enlargement, which is this point down here, 0, 0. Okay, so we got that. Now we need to find the scale factor. Now, you have 6 ways of doing this. You could use any one of these lines going like that, so that's 1, 2, 3, or you could use corresponding sides of the shape. I find it easiest to just use a line. I put a ruler from here, across here, I measure from there to there, and then I measure from here to here, and express this larger measurement as a ratio of the smaller measurement. So let's see that. Measure the distance B prime O, which is this larger distance here, and BO, the smaller distance. Set B prime O, the larger distance, as a ratio of BO. So if I measure this larger distance here, I get 8.1 centimeters. That's the image distance. And the smaller distance here, I get 2.7 centimeters. Now, it is always the ratio of the image distance to the object distance, or the image size to the object size. So K, which is the scale factor, 8.1 centimeter divided by 2.7 centimeters, and I get 3. Now, this is a ratio. It has no unit. It simply means that the image is 3 times larger than the object. So we can conclude it's an enlargement with a center of enlargement at 0, 0 and a scale factor of plus 3. We can safely conclude that. Example 3. Consider the diagram below, and you're given some data about the diagram, which is this. Describe the transformation of the object into the given image. So this is the object, this is the image on the left-hand side. Now, if you carefully follow this data, you will find out that you have enough information to say that those two items, the object and the image, are congruent. And if they are congruent and they are facing each other, most likely it will be reflection. They are the same size, that's the congruency. We can measure just now that the image distance is the same as the object distance. We can measure that just now. And we have lateral inversion. So most likely it is reflection. Let's verify that. Use a ruler to measure B to B prime. That's B to B prime and divide by 2. So you divide by 2, that's where you would arrive. That would be the midpoint. Then you use a ruler to measure D to D prime and divide by 2. D to D prime and divide by 2. So that would be the midpoint. Draw a line through those 2 midpoints to show the mirror line. So you draw lines through here. This is that blue line, which is the mirror line. So this is just showing one of the measurements where that distance is 2.5 centimeters and this distance over here is 2.5 centimeters, and you would have done the same thing with that other line down there with different measurements, but you would have found that the image distance is the same as the object distance. So we have reflection. We also need to know where is it reflected. What is this line? Well, that is x is equal to 0. You don't have to do any calculation on that. the simple x is equal to 0. Example 4. You have an object here and you have an image there. So you consider the diagram below and you're given some data. Describe the transformation of the object into the given image. This object became that image. Now, if we look at the data, we will see that A, B, which is this side, is equal to A prime, B prime. We will find that B, C, which is that side, is equal to B prime, C prime, and angle B is equal to angle B prime. Angle B is equal to angle B prime. So we can say that those two items are congruent. That is to say that the image is congruent to the object. And because it's congruent, there are a number of questions we need to ask ourselves. So from the given data, the image is congruent with the object. Is it translation? No, since all points of the object did not shift in the same direction, and therefore the image does not have the same orientation as the object. It's not like you take this object and push it that way. So the image will look just like this object shifted that way. No. So it's not translation. Is it reflection? No, since there is no lateral inversion. There is no line between here that one looks like the mirror image of this one. No. So that means that by the method of elimination, so it's not translation, it's not reflection, so it must be rotation. Now that we know it is rotation, we need to find the center of rotation and also the direction and angle of rotation. This is a little harder than the other three we just did. To find the center of rotation, you draw a construction line between two corresponding points, say A and A prime, and bisect it. So A and A prime, you draw this construction line and bisect it. Then you draw another construction line between another two corresponding points, say B and B prime, and bisect it. B and B prime. You bisect it and you get this bisector here. Now extend those two bisectors if you need to until they intersect. The point of intersection is the center of rotation. So this bisector arrives here, that bisector arrives here, that point there is the center of rotation. Now, you can do C and C prime if you want, but you don't have to. But if you do that, and this is a bisector from C and C prime, notice it still arrives here. So you don't need to do all three of those bisections. Two will suffice. So this is, third one is not required. So we know the center of rotation. We now need to find the direction and angle of rotation. We know the center of rotation. We know it is rotation. So we have to determine the angle and direction of rotation. So this is fairly simple. Set your compass point at the center of rotation and draw an arc from any point on the object to the corresponding point on the image, say A to A prime. So set your compass here, draw an arc from A that way to A prime. Notice the direction, and you could do the same thing with B to B prime and C to C prime, but you don't have to, like that and like this. So the question is, in which direction did you move that compass? The rotation is anti-clockwise or counterclockwise, so we know that much. But we also need to know the angle. We need to determine the angle as well. So we know its rotation, we know the center of rotation, we know it's anti-clockwise. How much? From the center of rotation, which is 0, 0, draw two construction lines to any two corresponding points, say B and B prime. So from here, draw a construction line to B, which is this red line, to the corresponding point on that side of the image, B prime. This line and that line. And now we will measure this angle from here to there. From here to there. From here to there. And what do we get? 90 degrees. So it's a rotation of 90 degrees anti-clockwise at 0, 0. Now you could write it in notation form as this, that the object points map onto the image points through a rotation at 0, 0 of 90 degrees anti-clockwise. Now, I did tell you this one was a little harder than the other three. So we just did run 1, where we looked at those 4 transformations and their images. We looked at translation first as example 1. Then we looked at enlargement as example 2. We looked at reflection as example 3. And we looked at rotation as example 4. That was run 1. We are going to do our run 2, cover those same grounds, but not in that order. So we will look at another 4 examples, 5 to 8. And once we finish that, we will go that over again with run 3, the same 4 transformation, but not in that order nor this order. We'll change up the order here. So run 2. Example 5. This is the object. That is the image. Notice that image is smaller than the object. Consider the diagram below and you are given data. Describe the transformation of the object into the given image. Now, if you follow that data, that the 3 corresponding angles are equal, that each pair of corresponding angle is equal. So you have similar triangles. However, you have opposite orientation. Normally in similar triangles, you have the same orientation. But notice B is up there and B prime is down here. C is to the right here and C prime is to the left of the image. So you also have different orientation. This happens when the enlargement is negative. Notice I said enlargement. I'm using that technically, even though the image is smaller. It is still called enlargement. So we know it's enlargement. So what is the center of enlargement? And what is the scale factor? To find the center of enlargement, draw at least 2 pattern lines through 2 corresponding points. Say A to A prime there and B to B prime there. You find that those 2 pattern lines will meet at that 0, 0 position. At least 2. You can do it with C as well for the third one, but you don't need to. So those are the pattern lines. As I said, you just need 2. The point where they intersect is the center of enlargement, which is here, 0, 0. So now we still need to know the scale factor, K. As I said, you have 6 ways of doing that. You could use any one of these pattern lines, or you could use corresponding sides of the image and the object. As I said, for me, it is easiest just to measure one of these lines. So I set my ruler here at 10, and I can easily measure going this way and coming this way, whatever is easiest. So to find the scale factor, you measure the distances B prime, 0 or O, and B, O, that distance. Set the image distance as a ratio of the object distance, always image distance, or image size if you are using the side. If you measure that side, set that as a ratio of this side if you are using corresponding sides. If you are using corresponding sides. So I measure that and I get 6.4 centimeters. I measure this and I get 3.2 centimeters, but I list it as negative since it is in the opposite direction. So I divide the image distance by the object distance and I get negative 0.5. So we know the center of enlargement is 0, 0 and the scale factor K is negative 0.5. That was example 5. 5. Example 6. Look at these two. Describe the transformation given an object and its image. That is what we are doing. Well, first of all, we have to determine if these two shapes are congruent. And we have enough data here to say that the image is congruent to the object. You'd have to take some time and verify that. So is it reflection or is it rotation? At first glance, it looks like reflection. Like there's a line somewhere in here. That is A, this is A prime, that is C, this is C prime, that is B far over on that side, this is B prime far over on this side. So it's not rotation. And of course, it's not translation, because translation will also have the same orientation. So it's not rotation, because while that may satisfy rotation, this does not. That is C. This point here should actually be B prime, and that point down there should be C prime. So it's not rotation. Get rid of rotation. So most likely it is reflection. So that's the object. This is the image. Draw construction lines connecting at least two corresponding points. And what I have done here is connecting A to A prime and C to C prime. I am going to bisect those two connecting lines like those. Draw construction lines connecting at least two corresponding points, and then bisect and join those two bisectors to form a straight line. This becomes the mirror line. This line here, from there to there. So this here is our mirror line. If we want to verify it, we measure B to B prime, divide it in 2, and see that this is the midpoint to give us the mirror line. So that side is 6.7 centimeters. This side is 6.7 centimeters as well. So we know that this line passes through the center. Well, you don't need to do that for these two because you already bisected them. You know that's the center and that's the center for those two lines. Now, we also need to say what is the equation of that mirror line. In this case, it is not difficult to say. Y is equal to X. If you consider any coordinate on that mirror line, for example, that point there is 5, 5. This point here is -4, -4. This point here is 7, 7. So X is equal to Y. So in this case, it is fairly easy. So now we can say its reflection at the mirror line, Y is equal to X. Now there is a more certain way of doing that. You don't need to do this, but you can if you want. We could pick a point here, say 3, 3, and another point there, say -4, -4, and find the equation of a line passing through those 2 points. We already know that Y minus Y1 is equal to M, that is M, times X minus X1. You substitute the Y1 and the Y2 values, the X2 and the X1 value, and you work that out, and you will still end up with Y is equal to X. Now, that's a hard way of doing it. You don't have to. But if you have to prove that, then yes, you will have to pick 2 points and work it through. So its reflection at the mirror line, Y is equal to X. That was example 6. Example 7, that's the object, that's the image. Consider the diagram below. You are given some data. Essentially, you use that data to ensure that the image is congruent with the object. And if you go through that, you would find, yes, they are congruent. So congruent and same orientation. This is about the easiest one you can get. Congruent, same orientation. So that means definitely it is translation. But you now need to say what the translation is. If you are given a graph like this, it's fairly easy. Pick a point and its image, like D and D prime. come across this way, count how many of those units you have crossed, go up that way, how many you have gone up. So this is 7 from here to there, and from here to here is 5. So the translation on this column matrix is P is 7, 5. If you are asked to do that without the benefit of a graph, and you are given this data here and told that a point D on an object is -3, -6, and its corresponding point on the image is D prime 4, -1. Describe the transformation of the object into the given image. And you're also told that the transformation is a translation. You have to know it's a translation in that case. But here you are given the drawing or the graph or the picture, and you had to determine that it was a translation. But in this case, if you have to determine the transformation matrix, you would have to be told that it is translation. So you are given this point, D, and this one, D prime. We use this equation here. P prime minus P is equal to T. That is any point on the image minus the corresponding point on the object is equal to the column matrix translation vector. So we put in the information we are given, P prime, which is this, and P, which is that. We subtract P from P prime, and we get the translation vector, which is 4 minus -3, which is 4 plus 3, which is 7, and -1 minus -6. So that's -1 plus 6, which is +5, and we get back the same translation vector we had down here that we got using the graph. So we can comfortably say it's translation, and that the translation vector expressed as a column matrix is this. That was example 7. Example 8, we have these two. This one is the object. This one is the image. You are given some data, and you are given that side is equal to that side, this side is equal to this side, that angle in between them. So essentially, you have two sides equal and the angle between. You have determined that the image is congruent to the object. From the given data, the image is congruent with the object. So is it translation? No. Since the points on the object did not shift in the same direction, and you don't have the same orientation to produce this image. You didn't shift that object down this way. If you did, you would have the same orientation. So it's not translation. Now, is it reflection? No, since there is no lateral inversion. Do you have a line going through here where you have one side facing the other, exactly opposite each other? No. Then, by the method of elimination, this must represent rotation. So it's rotation. It's not translation, it's not reflection, it must be rotation. Now that we have settled that, we still have 3 things to do. We need to find the center of rotation and the direction and angle of rotation. Center of rotation is not difficult to find. Draw a construction line between 2 corresponding points, say A and A prime, and bisect it. So this is A, that is A prime. This is the construction line, we bisect it, and it actually is this y-axis. It's the y-axis. Next, we draw another construction line between 2 other corresponding points, say B and B prime, B and B prime. We bisect it, which will be this bisector here, that bisector there, that one. If needs be, project or extend those 2 bisectors until they intersect. You didn't need to do that in this case because this bisector came down here, that bisector came across here. They do intersect at this point. So that's the center of rotation. This is optional. You could do the same thing with C and C prime, but again, it's optional. And as it so happened, the bisector of this construction line is that same previous bisector we had there. So it actually didn't make any difference. Now, we want to find the angle of rotation. Use your compass to draw an arc from a point on the object to the corresponding point on the image. In this case, I am using C. So I place my compass here, draw an arc from here, coming around to C prime. What direction was that rotation? From here, this way. Clockwise, of course. So now we know it's rotation clockwise. We need to know how many degrees. So at this point, we can say that the transformation is a clockwise rotation and the center of rotation is 0, 0. We still need to find the angle of rotation. From the center of rotation, 0, 0, draw two construction lines to any two corresponding points, say A to A prime. So from here, draw a construction line to A and go out this way to A prime. So now you have an angle formed here. Let's measure that angle. Measure this angle. We put a protractor. We measure from here, go all the way around to there. And we have 150 degrees. 150 degrees. So it's a rotation of 150 degrees clockwise. You can set it like that. Points on the object maps onto points on the image through a rotation at 0, 0 of 150 degrees clockwise. That was example 8. So we did, first of all, 4 of these. Then we did a second run of those same 4 transformations in different order. Now we are on our last run with another 4. We will go over these 4 transformations in a different order from that and that. If you feel comfortable, you could stop here. You don't need to look at this third run. But if you look at it, it will just reinforce the concepts that we have been learning. Example 9. You have these two here. Consider the diagrams below. The image is congruent to the object. Okay, this is the object. This is the image. You are told that they are congruent. This makes it easier for you. Describe the transformation, because that's what we have to do. Describe a transformation given an object and its image. That is what we have been doing in this objective. Well, this looks like a translation. No mirror image, nothing turned around. It's congruent, same orientation. So we can comfortably say translation. Everything here was moved that way. So we need to say how much did it move. So let's take 2 corresponding points. You could take any 2. I am using C and C prime. You could use B and B prime or any other 2. Now I come across like that until I reach opposite C prime and then come down this way. So I come across here and then I come down this way. How much did I go this way? 11, but that's negative 11 because I'm moving in that other direction. And coming down here, that's 4, which is negative 4. Remember, that way on the y-axis is positive. So the translation under the column matrix is negative 11, negative 4. And we can stop there. However, if you are not given this diagram and you are given a point on the object and the corresponding image point, you are to describe the transformation given that it is a translation. In other words, what is the translation vector? So this point here is 2, 6. This point here, which is the corresponding image point, is negative 9, 2. We use this equation here, substitute the coordinates we are given this way. P prime, which is that, and P, which is this one here, subtract them, and we will get the translation vector expressed as a column matrix. Negative 11, negative 4, that is. Negative 9 minus 2, which is negative 11, and 2 minus 6 is negative 4, which is the same thing we had down here. All right, that was example 9. Example 10. Now, just looking at this, I think you can comfortably say this is a reflection. You have A here, A prime here, C there, C prime there, B way over there, and B prime far out on the other side. So it looks like there is a mirror line somewhere between here, and that's the object. This is the image. It looks like a reflection. Of course, we have to determine that those two are congruent. And we have enough data here to say that they are congruent. You're given two sides and an angle in between. So they are congruent. So we can comfortably say they are congruent. It's not a rotation. If it were a rotation, that AES could be A prime, but that B here will not be quite down here. That B will be somewhere higher up there, and that C will be further down here. So no, that's not a rotation. So let's find the center of rotation. Draw a construction line connecting two corresponding points, say A and A prime, and bisect it. A and A prime bisected. So we have this bisector here. Well, you do the same thing. Draw another two construction lines, say C and C prime, and bisect it. This one here and that one there. You could have used B and B prime, but you try to get points as farthest apart from one another. So you bisect it. So this is the bisector. And then you join those two bisectors to form a straight line. This becomes the mirror line. If the bisectors do not touch, extend them until they touch. Okay, if you had the bisectors like this, you would have to extend them until they touch. So that's our mirror line. You can measure this just to verify that this distance here is the same as that. Of course, we already know that this is the midpoint of C, C prime, and this is the midpoint of A, A prime. We already know that because we bisect those two lines. So accurately measure the image distance and the object distance. Just to confirm, you get this is 5.7 centimeters. That is also 5.7 centimeters. So now you are sure that we have a mirror image here. One last thing. What is the equation of that mirror line? We can take 2 points. This is not as easy as the previous one that we did for reflection. We take 2 points, P 64, which is here, and the point over here, which is R, -4, -1. If we have 2 points on a straight line, we have a formula to find its equation. The formula is this. Y minus Y1 is equal to M, that's M, times X minus X1. We substitute the numbers we are given for Y1 and Y2 and X1 and X2, and we work it through, and we get Y is equal to 0.5X plus 1. Because you have to give the equation of the mirror line when you do this. So it's reflection at the mirror line, Y is equal to 0.5X plus 1. Example 11. This is the object. This is the image. First of all, we have to determine if the image is congruent with the object. And based on the data here, we have all three corresponding sides equal. So the image is congruent with the object. So from the given data, the image is congruent with the object. All three corresponding sides are equal. So is it translation? No. Since all points on the object did not shift in the same direction, no same orientation to produce the image. If it were translation, that whole object there would shift this way, and you would have the same orientation, but you don't have the same orientation here. A is down here and A prime is above there. Okay, so it's not translation. So is it reflection? No, since there is no lateral inversion. If it were reflection, you would have a line passing through somewhere here so that this A would reflect across here to A prime, which is not what we have, and that C would reflect over here. There is only one exception to that. If the reflection took place at this point, then yes, that A would become A prime up there, but then those two distances would have to be the same. The image distance would have to be the same as the object distance. We don't have that here. So it's not reflection. So that leaves us with rotation. So we can say it is rotation. Now we need to find the center of rotation, which is fairly easy, and the direction and angle of rotation, which is a little harder. Now, by the way, if you are not given this data up here, you are just given the drawing, you would have to take some measurements to ensure that these are congruent to each other. So you can measure the 3 sides, or you can measure 2 sides and the included angle. From the given data, the image is congruent with the object. All 3 corresponding sides are equal. So draw a construction line between 2 corresponding points, say A and A prime, and bisect it. A and A prime bisected, which is the bisector. Do the same thing with another 2 corresponding points, B and B prime, B and B prime, and bisected. This is the line, and that is the bisector. Now, if needed, extend those 2 bisectors until they intersect. The point of intersection is the center of rotation. Here, center of rotation is -3, -2. If you want, you could have done the same thing with C and C prime. Bisect that, you will get the same point here. But you only need 2. So that third one is optional. Now use your compass and set it at -3, -2, which is here. Draw an arc from a point on the object, say A, to the corresponding point on the image, say A prime. So you draw an arc from here, come around this way to A prime, using this as the center. Question is, what is this direction that you draw that arc in? And it is clockwise. So at this point, we can say that the transformation is a clockwise rotation, and the center of rotation is -3, -2. Finally, what was the angle? We still need to find the angle of rotation. From the center of rotation, draw 2 construction lines to any 2 corresponding points, say B and B prime. Say from here to B and from here to B prime. Those 2 lines, and we will measure the angle so formed between them. We will measure that angle. We measure it from here, go all the way around to here. Actually, it looks like 161, but we can round that off to 160. We can say it's 160. If you say 161, fine. So it's 160 degrees clockwise. So we can conclude this example by saying it's a rotation of 160 degrees clockwise at the center of rotation, -3, -2. You can state that like this. That was example 11. Finally, example 12. You look at this, and this looks fairly easy. This is the object. This is the image. It looks like enlargement, except that if this is the object and this is the image, then the enlargement has to be somewhere between 0 and 1, and not negative either. So if you consider the data you are given here, we find that 3 angles are equal, which means that the 4th one is also equal, corresponding. So we have similar figures, similar shapes, same orientation, which means that the enlargement is not negative. If the enlargement were negative, then the center of enlargement will be somewhere here. Since the two shapes are in the same orientation, then the center of enlargement would have to be somewhere on this side here. So it's enlargement. We need to find the center of enlargement and the scale factor. This is fairly easy. Draw pattern lines through corresponding points. You only need two. I have 4 here. So from C to C prime, extend it. From A to A prime, extend it. We only need 2. I have 4. So I have 4 pattern lines. The points where they intersect is the center of enlargement, which is here. O, -4, 3. Now, what is the scale factor? You have 8 options. Use any one of these lines or use any pair of corresponding sides. I am using this one line here. I can easily measure from here to there. That will be the image distance. And I can measure from here to there. That will be the object distance. So I measure that and I get 5 centimeters. That's the image distance. I measure from here to there. I get 12.5 centimeters. That's the object distance. So the scale factor is the ratio of the image distance to the object distance, which works out to be 0.4. So it's enlargement with the center of enlargement at -4, 3 and a scale factor of 0.4. Now, as I said, you could have used any of the pattern lines like this. I am doing this other one. From there to there is 7. From here to here is 17.5. If I set up the ratio, I still get 0.4. Or you could have used any pair of corresponding sides. I'm not showing that here. You could have measured this side here, C prime to D prime, and C here down to D. Remember, it is the image side over the object side, or the image distance over the object distance. And that was example 12. Describe a transformation given an object and its image. So we looked at these 3 times, each one. So that brings us to the end of video 19, based on objective 10 in section 8.